Hi students, these are the notes for section 2.1, and hopefully you have talked about some of the different types of numbers that we have, and so most of this lesson should be review. I'm hoping that I will have my pen working here. So I need to get back to, there we go. The natural numbers, or the counting numbers, are the set of numbers, whoops, come on, that we count with, and so that would be 1, come on, be 1, okay, just a second. So that would be the numbers 1, 2, 3, dot, dot, dot. And because in mathematics we often like to use abbreviations, instead of writing out natural numbers or counting numbers, you will often see mathematicians use the letter N, capital letter N. I hope you can read that. Okay, the next set of numbers are our whole numbers, and they are all of the natural numbers, 1, 2, and 3, and so forth, as well as the number 0. And I often remember these because whole is in the word whole, and it does look like a 0. The abbreviation for the whole numbers is the capital letter W. The integers are all of the whole numbers, as well as all their opposites. And the opposite of 0 is 0. The opposite of 1 is negative 1. The opposite of 2 is negative 2. And I need to get my 3 dots in here. And so on. So there is no smallest integer, nor is there a largest integer. The current Algebra 2 book that we use for the honors students uses the letter Z for the integers. So we might as well just use the letter Z for us. And I'm going to put a dash there so we don't think at all that it's a 7. The rational numbers are the set of terminating. Come on, pen. Terminating. Or repeating decimal numbers. And always numbers. The other way to give the definition is to give it as a fraction, and so the rational numbers would be the set of all fractions, and we would write that as A over B, where A and B are integers and B is not equal to 0. Because if it were 0, then we would be trying to divide by 0, and that is undefined. The short way of writing the set of rational numbers would be a capital R. The irrational numbers are the set of numbers that are non or not, so non-terminating. Okay, let's try to get our pen again working. Okay, I will pause a second while I get my pen. Okay, so I have to go back and do the irrational numbers. They are the set of non-terminating or non-repeating decimal numbers. An example here is 0.12, 13, 14, etc. It does not terminate. It does not repeat with a repeater bar, but we definitely see a pattern. Other numbers would, again, be many of our square roots, especially where the radicand is not a perfect square. There is really not an accepted abbreviation for irrational numbers, and in all my years of doing math, I've never had to just deal with that group of numbers. The real numbers are the set of rational or irrational maybe running out of space there. Irrational numbers. So both of these sets are in the real numbers, and for the abbreviation we either use this double bar with a printed R or we use a cursive R. I'm going to Okay, the absolute value of a number b is written this way, and with the b in absolute value bars. And as we said, I think it was last week, that it stands for the distance b is from 0 on NO is number line. A conditional statement has a hypothesis and a conclusion. The hypothesis is always true, and the conditional statement will be true if the conclusion is always true. If there's one instance where the conclusion will be false, then we have to say the conditional statement is false. An if-then statement is a form of a conditional statement. The if part, the part of the statement that comes after the if is the hypothesis, and the part of the statement that comes after the then is the conclusion. So in this example, if a number is positive is the hypothesis, so that must be true. So we must pick a number that's positive, let's say 12. Then its opposite is negative, and the opposite of 12 would be negative 12. I think I hit a clicker on my pen and that's making a difference here. And it wouldn't matter what positive number we pick, its opposite is always going to be negative. So this conditional statement would be true. The next conditional statement, the hypothesis is a number is a rational number. That must be true. So we must be talking about a number that can be written as a fraction or a terminating or repeating decimal. Then the number is positive. So I could pick the number 1/2, and certainly it is positive, but I could have just as well selected the number negative 3.1, and it is negative, not positive. And so this statement, conditional statement, would be false. This one, of course, was true. The counterexample, we give a counterexample when a statement is false. We're giving a time when we can select a number that makes the hypothesis true but the conclusion false. And so our counterexample would be when the number is equal to negative 3.1. And we could write out in words, negative 3.1 is a rational number, but it is not positive. I hope you're able to see all these notes, and I look forward to seeing you in class on Friday. Take care.